Okay, hello everybody. Alex, thank you for inviting me and giving me a chance to talk at this event. So, my name is Andrej Popov and I'm working at the Anisoft company. Today we will speak about the content protection and security of Dash. And so, imagine you finally get this, approval from your boss, and he wrote you a big check. You run to the store, bought all the servers to compress all your important videos, HEVC, and spend a lot of resources to do that, and it's quite valuable content, and you obviously would like to secure it in order to monetize that. So the Dash IF is provide you tools and multi-DRM framework in order to achieve that goal. Dash IF does not define single DRM systems, rather than it provides you ability to provide the DRM agnostic solution by calling common encryption. The common encryption allows you to use single encryption key and define the key mappings mechanisms in order to encrypt and secure your assets. So Dash IOP define common encryption schema, some base technologies, ISO BMFF support for common encryption and DRM, and that section quite big, so we don't have time to really deep dive into that, but it's basically summarized and explains which necessary boxes you need to configure in order to apply the encryption. MPD support for encryption and DRM signaling, some additional content protection constraints, and the transport security in HTTP-based delivery. So the common encryption itself specify and provide you the information how you can encrypt null structure videos and other media data with the IES 128 CTR mode. Now, recently, there is activity from Apple also to support CBC mode, but within the Dash, it's not supported, so we're focusing on IES 128 CTR mode. It also defines how to decrypt single representation by multiple DRM systems, key rotation, and the syntax for expressing default key IDs within the MPD, which is manifest. And some typical scenario where you need certain amount of input parameters in order to produce the encrypted content. And the parameters are basically the common key ID, the actual content key, and Dash clear content. So you specify that, and the scrambler or encryptor can produce MPD with the necessary information inside, like default key IDs and the PSSH box. Now, the PSSH box, it's that piece of data which contains the DRM specific information. So that's how you define necessary settings for, let's say, Play Radio, Widevine, or Marlin, or other types of DRM systems, so that player at the end knows what to do and how to retrieve the license. So baseline technologies which are used are content protection descriptor in the MPD, and that provides you ability to signal to the player that the content is encrypted, and also notify players about which DRM specifically it can use in order to decrypt content. It also, there is a required boxes within the media file format, like to specify the encryption parameters and default key IDs, parameters required to store initialization vectors and subsample encryption ranges, and specify the license acquisition data for the keys for each DRM. So one of the workflows to produce the encrypted content involves lots of different entities. And DASH-IF also provides some guidelines how companies and different vendors can actually create interoperable documents in order to exchange these keys between multiple entities. So Content Protection Information Exchange Format, version 2.0, provides basically the information how you can provide the keys to each entity, how you can secure these keys, how you can define necessary settings for each entity, and how these keys can be used within this entity. For example, the encoder encodes the content, then provided to the packager encryptor, and encryptor needs to take the keys in order to apply the encryption. So the keys could be fetched from the DRM service, or in some cases, there is encryptor model already integrated within the encoder. And then in that sense, the encoder needs to fetch the encryption keys from the DRM service or content provider, so it can actually request the data, and with the defined specification, the DRM service or content provider or any other entities can provide this information to the encoder, and then the encryption can be applied. Now, some of the workflows for the requesting the DRM license outlined here, and player first needs to fetch the MPD. So, okay, so there is a few aspects. Remember, I said the PSSH box, right, which is important, which is gives player knowledge about, which DRMs it can apply in order to decrypt the content. So you can specify the PSSH box within the MPD or initialization segment inside of the media file format, which gives the player ability to fetch the data, validate it, and then make a decision. Okay, now this is encrypted with the play-ready. Let me communicate with the play-ready DRM service. It will take this PSSH box and will send it to the license server with some additional authentication parameters, obviously, but in a high level, the DRM server will send the license response back, its encrypted response, which contains the content key. And as I said, right, so it's because it's a DRM agnostic, any DRM system can be applied, so you can have multiple PSSH boxes within the MPD or initialization segment. Now, it's recommended to specify the PSSH box in the MPD for various reasons. One of it, that the player can faster obtain the necessary information in order to retrieve the license to play back the content. If you specify the PSSH box in each initialization segment, that could cause some of the unpredictable behavior especially for the web browsers, DRMs, agents, and the players. So as soon as the license received by the player communicates back with the DRM clients, and the DRM clients is basically the core of the security components on each player. And the DRM client can be implemented either as a software-based or hardware-based. So today there is a notion that hardware-based DRM is more secure. However, in my previous experience, basically software DRM has not been compromised. So we can say you go with a software-based DRM, it's still very secure. Hardware-based DRM obviously dependent on the hardware implementation, so you'll need to have devices which implements the DRM decryption mechanisms within the chipset. So the license retrieved, the license provided to the DRM client, it performs the content decryption and sample decryption and then decode the content. Now, to signal to the player that the content is encrypted, we normally use the MPD, and as I said, that's a preferable way for various reasons. And we basically have a content protection element, which specify the, which signals that the content is encrypted, and then it provides this proprietary information which each single DRM system needs to retrieve in order to generate back the license to the client. Okay, so the Dash IF, I mean, in the MPAC Dash, you can explicitly permit also to use the HTTPS as a schema and enhance the HTTP over the TLS. However, you know, there is some impacts of using HTTP in Dash, and at some point it could be challenging in maintaining. And some of these challenges are related to CDN network and efficiency. So in case of the CDNs, the way SSL works, it's basically, it's encrypting connection between client and server for each HTTPS session. So it's quite challenging to cache the actual payload data. Now, for network, because the client and server establish the secure HTTP tunnel between each other, it's impossible for underlying networks to manage and optimize encrypted data traffic. So there is some challenges presented as well with that. Now, in terms of the efficiency, the DRM itself already provides the encryption layer for the payload data. So we call it, you know, sometimes redundancy because you do the double encryption. However, yes, you know, there is HTTPS could be used for a variety of reasons, for privacy, as an example. So I intentionally left some time for the questions. If you have any questions, please let me know, and I will be helpful.